All right, so in 5.3 we talked about solving the trig equations, right? So this time you're given the answers and you're giving me the angles in radians. And this time, this should have had a bracket, well, here, a bracket and a parentheses, okay? This is actually saying on the interval of 0 to 2 pi. So we're going to talk about what it would look like if it's 0 to 2 pi, and then we're going to talk about what it would look like if it didn't, because your quiz could have both. So it says to, obviously, first we're going to start by either solving them, factoring them, whatever we need to do. Number one is already done for you. It's already factored for you. So you would just split this and set them each equal to 0. And I would get tangent of 3x equals 0. And I would get tangent of x equals 1. So the right-hand side of this is a normal one. We would just figure out where tangent is positive 1, which happens at pi over 4. And also at 5 pi over 4. Because it's on the interval of 0 to 2 pi. So it's everywhere on my unit circle where tangent's positive 1. So remember that tangent, the over 3's are root 3, the over 6 is root 3 over 3, and the over 4 is your 1. And then obviously the signs change. The other one on the other side, this is one of those multiple angle equations. So it says the tangent of 3x is 0, not just x. So the first thing you're going to do is figure out where tangent is 0, and this happens 2 times on my standard unit circle, once at 0 and once at pi. But in this case, we're saying 3x equal these, not x. So then we have to take it one step further, divide by 3. This one doesn't change, divide by 3 here, and it does. So the answer to these, God bless you, would be all 4 of those, where x is 0, where it's pi over 4, where it's pi over 3, and where it's 5 pi over 4. If it didn't give you that interval, then you'd be looking for where negative pi over 2 to positive pi over 2 tangents answers are these, and then adding n pi. So in that case, I would have gotten 0 plus n pi for the first one. And then this one gets tricky because it would have been plus n pi here. Actually, no, it would have been plus n pi before that. It would have been plus n pi here. And we would have divided everything by 3, so this would have also gotten the 3. It would have been n pi over here. And I would have gotten pi over 3 plus n pi over 3. And then it also would have been, oh, so this should have had the over 3. And then it also would have been these two, actually not, you don't need this one. So you don't need this one either because it takes care of it in the first one. It would have been pi over 4 plus n pi. So remember for tangent, we add n pi. And for sine and cosine, we add 2n pi. That's if it does not give you the interval. So this time it gave you the interval. That's why these answers are correct. If it didn't give you that interval, then you would need to know to add the n pi on for tangent. Mary Angel.
Why did you cross out the pi over 3 to the n pi?
Because you don't need it. Because if you have this, right, and I do 0 plus n pi over 3 and I make n1, I get pi over 3. So for tangent, you're only looking for this quadrant and this quadrant because you add a half a circle on every time, which is at n pi. So if I grab the 0 here and I add pi over 3, it gives me the other pi over 3, so you don't need it. So for tangent, you only grab from negative pi over 2 to positive pi over 2, but you add n pi because it happens every half circle. Gia.
So then you can also cross out the pi over 3 in your answers.
So in the initial answers, all 4 of them are there because the actual directions here said this, right? For the if it didn't give you that interval, just this and this are your answers. All right, number 2 says secant squared minus secant equals 2. So for this one, the first thing I'm going to do is get everything to the same side because I know I'm going to have to factor this. I'd get secant of x, and then minus 2 and positive 1. Set them each equal to 0. And I get secant of x equals negative 1 and secant of x equals positive 2, which means the cosine equals its reciprocal. Reciprocal of negative 1 is still negative 1. reciprocal of 2 is 1/2. So again, the directions this time said everywhere on your initial unit circle, so 0 to 2 pi. So from there, I would say that cosine equals -1 at pi, and cosine equals +1/2 at pi over 3, and at 5 pi over 3. If it didn't give the interval, then my answer would have been pi plus 2n pi, pi over 3 plus 2n pi, and 5 pi over 3 plus 2n pi. So without the interval, because you're going to make sure you're paying attention to your directions on your quiz, without the interval, you add the 2n pi for sine cosine. With the interval, you don't need it, like you did for the first thing that's highlighted.
But don't you not need the 5 pi over 3?
So only tangent.
Is the one that you do that.
Correct. You mean without the interval, right? Because the highlighted part, you have to have them all the time. Everything that's on your unit circle from 0 to 2 pi that they give when they give you the restricted, you include. Only when it's without the interval tangent do you do half the circle. Okay, then I get to 3. This time I've got secant and I've got tangent, which means I got to get it down to one of those. Which one can you replace?
Secant squared.
You could actually replace either one, right? Yeah, so you replace secant squared with?
Tangent squared minus 1.
It should be +1, right?
Plus 1.
Yeah. 2 times tangent squared plus 1 plus tangent squared minus 3 equals 0. So 2 tan squared x plus 2 plus tan squared x minus 3 equals 0. Combine your like terms here. This would be 3 tangent squared x plus 2 minus 3 is -1 equals 0. Add the 1 to the other side. Divide by 3. Square root plus and minus, and I get tangent of x equals plus and minus the square root of 1 over 3, which is 1 over root 3, which is root 3 over 3. Again, on the interval, I'm going to include everything that's on my unit circle. So all, because it's plus and minus, it's all the over 6s. It's pi over 6, it's 5 pi over 6, 7 pi over 6, and 11 pi over 6. If it had said without the interval, I only need pi over 6 and negative pi over 6, and I would add n pi. So pay attention to the directions. You don't want to get those questions wrong or lose credit because you do the wrong thing. All right, questions on the homework? Okay, so this one said find all the solutions of the equation on the interval 0 to 2 pi. So if it's secant x equals 2, I'm going to flip it, so it's cosine x equals 1/2. And then interval 0 to 2 pi is your entire unit circle, so this is almost exactly like the warm-up. Cosine is 1/2 at pi over 3 and at 5 pi over 3. And those are the only two you include because it gives you the interval. This one, 7, said find all the solutions on the interval again, 0 to 2 pi. So this time it says tangent squared x minus 1 equals 0. Tangent squared x would equal 1. Tangent of x would equal the square root of 1 with the plus and minus in front of it. So we're looking for everywhere tangent is positive or -1 on that unit circle. This is all the over 4s. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Don't forget your plus and minus. 4, solve the equation 2 sine of x plus 1 equals 0. I'd get 2 sine of x equals -1, sine of x equals -1/2. This time it didn't give me my interval, so I'm looking for where it happens on the circle for sine, but then I'm going to add 2n pi. So sine is -1/2 in the third and fourth quadrant, and it's where it's out the over 6s. So it's 7 pi over 6, and it's 11 pi over 6, and to each of these I'm adding 2 n pi. Five, 3 cotangent squared minus 1. So this would be 3 cotangent squared x equals 1. Cotangent squared x equals 1/3. Square root both sides. Cotangent x equals plus and minus the square root of 1 over 3, which is 1 over root 3, which gets rationalized to root 3 over 3. And it's plus and minus, so it's everywhere on my circle. It doesn't, actually, this is cotangent, so it doesn't give you the interval, so I'm going to flip it to tangent. Actually, I should have done that before I rationalize it. So it's where tangent is plus and minus root 3. And then because it doesn't give me the interval, I'm going to look at negative to positive. And I would have gotten pi over 3 plus n pi, or negative pi over 3. This, actually, WebAssign allowed for the 2 pi over 3, because it also happens there. That's fine. It's not really wrong. Like, I would have taken either answer. It's not wrong to include the positive as long as you have the interval, because technically this would give you this, okay? So I would have taken either answer. So if you put in the negative and it marked it wrong, don't stress out about it, okay? That's the same thing. You just got to make sure you have 2 angles and then the half circle. 6 says cosine times cosine x minus 1 equals 0. So I would get cosine of x equals 0 and cosine of x minus 1 equals 0. So cosine of x equals 1. It doesn't give you an interval, so it's everywhere plus 2n pi. Cosine of x is 0 at 0 plus 2n pi. And cosine is 1 at, nope, sorry, cosine of, this would be your pi over 2. Pi over 2 plus 2n pi and 3 pi over 2 plus 2n pi. And then cosine of 1 is at 0 plus 2n pi. So it just didn't like the way you wrote that. You can't put the 0 there. The 0 would be the other spot. Yeah. Okay. So the 2n pi is the same thing as 0 plus 2n pi, right? And then the larger value is this one. It just didn't give you the third option. Technically, this is still an answer, right? It didn't say, and as an integer is constant. Yeah. Because it should be both. It just didn't give you that third option. Yep. Say that again.
Like the answer shows there plus n pi.
Because this would be the same as writing both of these. Does that make sense? It happens every half circle there. So if I wrote n pi over 2 and I added 1 pi, I get 3 pi over 2. And then I added another n pi, I get back to the top. So that's the only time that works, though, because it's the only time that your value, well, that's not true, because you could do it at 0 and pi for sine. It just took those two answers and put them into one by eliminating the other half the interval. Yeah. So quiz-wise, you can give me what's on the bottom because it's the same thing. And it's less confusing. But that's why it eliminated half that interval. Okay. All right. So 5.1 and 5.2 had the same bank of references. Okay. This is all of your identities, your fundamental identities. And then part of the quiz is going to ask you just to simplify what's there. And then the other part's going to ask you to verify what's there, where your left side has to equal the right side. I want to stress that you have to show your work on these. Obviously, you know if it gives you the left side equals the right side, what your answer is supposed to be. But without the steps in between, you will not get credit for the question. So the reciprocal identities are the ones we've been dealing with the longest, right? So this would be like secant of theta is 1 over cosine. Cosecant of theta is 1 over sine. Cotangent can be written as 1 over tangent, or it can be written as cosine over sine. and tangent would be 1 over cotangent or sine over cosine. And if you need to work in the reverse, you can say that cosine is the same thing as 1 over secant, and and sine is 1 over cosine. So however you need to work those through, you want to make sure that you be able to replace those. Then came the cofunctions. This is your partners that deal with complements. So if I said sine of theta, it's the same thing as the cosine of pi over 2 minus theta. And vice versa. Cosine can be replaced with, or actually it should be the other way around. Sine pi over 2 minus theta could be replaced with cosine. Then tangent went with cotangent. So tangent is the same thing as cotangent. God bless you. Pi over 2 minus theta. And cotangent is the same thing as tangent. Pi over 2 minus theta. And then cosecant went with secant. So secant is the same thing as cosecant. Pi over 2 minus theta. And cosecant is the same thing as secant. Pi over 2 minus theta. So you know that you can replace one with the other. Usually you're replacing the right side with the ones on the left for those cofunctions. Then came even and odd identities. Remember that cosine and its reciprocal function, which is secant, are the even ones. So if I said that the cosine of negative theta, it's the same thing as saying cosine of theta. And secant of negative theta is the same thing as saying secant of theta. Whereas, so these are the even ones. Whereas the odd ones, sine of negative theta is replaced with negative sine of theta. Cosecant of negative theta is replaced with negative cosecant theta. Tangent negative theta is replaced with negative tangent theta. And cotangent negative theta is replaced with negative cotangent theta. Then came the Pythagorean identities. So the one we know the best is sine squared x plus cosine squared x equals 1. If I divide them all by cosine, I get the next one, which is divide them all by cosine squared. I get tangent squared x plus 1 equals secant squared x. If I take my original and divide them all by sine, I get 1 plus cotangent squared x equals cosecant squared x. So remember, you can derive them if you get stuck. Take your initial one. Hopefully you have the initial one memorized. Take that initial one, divide everything by cosine, you get the tangent one, and then divide everything by sine, and you get the last one. Questions on the original identities? So obviously then you got to apply it, right? Some of them are going to say simplify, and you got to simplify, and some of them are going to say verify, where you got to get the left side to equal the right side. Everything that's on that is on Quizlet on the module underneath where it says 5.1 to 5.3 quiz review. So if you're a Quizlet person, okay, there's everything that's written there is on flashcards. Okay, just some examples. So these are the verifying ones. So pretend that the thing's not there on the right. This would be your simplifying. And then obviously if it's there, then it's your verifying. So if I had 1 plus tangent squared theta times cosine theta equals secant theta, what would you do? And there's more than one way to do this. Okay, so 1 plus tangent squared is in your Pythagorean identities. This could become secant squared theta times cosine of theta. Then what? Yep.
Change secant squared theta to 1 over cosine.
This could be 1 over cosine squared theta times cosine theta. Then when your cosines cancel, you get 1 over cosine theta, which is secant theta, equals secant theta. You're always going to go all the way to the last step where the left side equals the right. And yes, some of them could be that easy. Okay, you could have also distributed this. It would have been a lot messier, but you can get there. Obviously, look for your trig identities first. Okay, how about this one? Cosine to the third plus sine squared times cosine equals cosine. What would you do? Janet. Move the cosine over? Okay. Like that? Okay, then what? Then take a cosine out. Yep, thank you. Okay, then what? Sine squared, cosine squared. That works. Okay, you could have also taken cosine out from the beginning, right? It's actually, I don't think that it's any easier. I think they're both fine. Because then this becomes cosine theta times 1. It's like one less step, but honestly, it's not any different. Yeah, they're both right. Questions on that one? Uh-huh. All right, what would you do here? Okay. Change this side to make them what? Like sine over cosine or 1 over cotangent? Sine over cosine. Super easy, right? So I am not saying they will all be that easy, but you could get an easy one. The biggest thing is don't give up, because the easiest one might be the last one for you, right? Like, don't get frustrated. If you get stuck, you need to keep going. Go back to the beginning. Remember your tricks, like moving from the denominator to the top becomes its reciprocal function. Combining into one fraction, you might need to change them so they have the least common denominator. You can cross multiply. Remember all those tricks, because they're going to come in handy. Any questions on simplifying or verifying? Okay. Then came what we were talking about in 5.3. Okay. Remember, you need to know your unit circle, obviously. You don't need to fill the whole thing in. To be honest, I probably wouldn't. I would probably give myself my little, like, over 6 is root 3 over 2 and 1/2. Over 4 is root 2 over 2 and root 2 over 2. And then over 3 is 1/2 and root 3 over 2. And then the tangents at those places would be root 3 over 3, 1, and root 3. And then know your signs. Like, other than that, you don't need, like, I don't need the angles for sure in degrees, okay? It would be a waste of time to fill out your entire thing. So remember that if it's got an interval, like 0 to 2 pi, parentheses should be there, that you're going to give everything that's on your static unit circle, everything for sine, cosine, or tangent. If it doesn't say that, then for sine and cosine, you're going to add 2. That should be an n. It should be 2n pi. And for tangent, you're going to add n pi. And tangent, you're going these values. Negative pi over 2 to positive pi over 2. But sine and cosine, you're using your whole circle.
And then for cotangent, it would be the same thing, right?
Yeah, because you could flip it. Yeah. Like I would probably flip it so you don't have to know the other reciprocal. I mean, it is just the reverse of that, but I would probably flip it. So if you had something like 4 cosine squared x minus 3, you're going to make that 4 cosine squared x equals 3. Divide both sides. And then square root both sides. I'd get plus and minus the square root of 3 over 4, which is the square root of 3 over 2. So I'm saying plus and minus root 3 over 2, and this is the benefit of knowing this stuff over here. That's all the over 6 is. The over 6 is pi over 6. And it didn't give an interval, right? Plus 2 and pi. 5 pi over 6.